Hi, my name is James Cunningham, and today I'm going to take you through the 2013 higher level question B2. Now, in this particular year, the question B2 was the axonometric projections exercise. Okay, so just talk you through the question first of all, and we get started then on part A, B, and C. Soccer is one of the most popular team sports in the world. The 3D graphic on the right shows a set of typical soccer goals. So the graphic here shows your set of typical goals. Okay, figure B.2, so this area down here, shows an incomplete diametric projection of similar goalposts using the axonometric axis method. Okay, so diametric, so we know this little triangle here, when we have it drawn, we'll have two angles that are the same as regards the angle in degrees. Okay, the elevation and in view are shown in the required positions. So here you have the elevation and the in view of the goal, and a pictorial view of the goal post is also shown. Okay, down here. All right. First of all, the reason I suppose we have our elevation and in view is to give us the true shapes, if you like. We have the true shape here of that curve, for example, and that helps us to project our points back when we're drawing the pictorial view. Okay, we have our Y and Z axis. We have the angles in between those. That's given here 110 degrees, so there should be no problems with that. All right. The first part of the question is to draw the axonometric axis X, Y, and Z, and the isosceles triangle ABC, as you see it here. Okay, so I'm going to start off with that, and we're going to set up those axes as you see it there. All right. Generally, when you start off, you need to look at the sheet and kind of observe where exactly you're going to need the space. All right, are you going to have a plan view? If you are, you need to keep it up far enough. Are you going to have a elevation or an in view to the left? Just to be aware of that when you get started, that you come down far enough on the sheet. Okay, I'm just going to come down here. I'm going to start with my y-axis as you see it here. Okay, I'm going to pick the bottom point here, which is going to be the common point between the X, Y, and Z axis. We are told in the question that the angle between the Y axis and those is 110. So I'm going to line it up here, 0 right around to 110. Okay. Draw in my Z axis, and likewise I'm going to come around the other end, line up my central point of the protractor here, 0 on the line, and come around again to 110 degrees. Okay, so that basically is setting up your primary axis as you see it there, X, Y, and Z. Okay, and again, just no harm just to label those, just so you know which is which. Okay, X, Y, and Z. Okay, again, keep note, if you measure this bottom angle here also, you'll notice what's left on that then is the 140, and 140 plus 110 and 110 all add up to your 360 degrees. Okay, so not much different there regardless of what angle is left, but you will notice with any questions the three angles around the central point between both axes will add up to 360 degrees. Okay, the next part of that, which is also on part A, was to draw the isosceles triangle ABC. Alright, in this particular instance, we're not necessarily given the length of the baseline here. Okay, sometimes you may be told the length of this line. Sorry, we actually are, on this case, as you see it here, 7 meters. Now we're converting from one scale of 1 is to 100. Okay, so 7 meters were actually given in this case. If you were not given it, you draw a horizontal line across here from the Z to the x-axis at whatever height you find beneficial. Okay, the further you come down, the bigger portion of a plane you're going to be drawing. That's the difference. Okay, in this case we're told 7 meters. So what I'm going to do, just from the common point, the central point we call it here, I'm going to measure out a line. I'm going to come out half of the 7 meters, so half of it either side of your y-axis. So we'll have 3.5. Okay, I'm going to drop that down vertically until it hits the z-axis, and then bring that across to your x-axis. Alright, so just to go back on what I did here, Sorry, just missed a bit there. We're back over this horizontal line here, just with a yellow coloured pen, just to make it a bit easier to see. So that's A, B, and this point up here is C. Alright, the way we get point C here, when you have your horizontal line drawn across the bottom of the triangle here, so that's the horizontal trace of this triangle when you have it constructed. Alright, what we do is we extend out our x-axis here. I did in this case. You can do it the x or the z-axis. Alright, I extended that out as you see it here. Okay, when you extend that out, this point we have here, which is our point B in this case, comes up in this direction, and it must be perpendicular here to that extension that we're after drawing. So you must draw it up perpendicular there, and where that crosses the y-axis gives you your point C on the triangle, and then you project that down again to point A. Okay, so again, extended this x-axis, bring up your point then from point B. Alright, so if you line up your sliding set squares there with that x-axis, slide your set square up then, and you have your 90-degree angle there from point B up till it crosses the y-axis. Get that point C here, and you project it back down to your initial point A. And that's the first part. That's your axonometric axis X, Y, and Z drawn in place, and also the isosceles triangle ABC. So there's not much different there with any question. I suppose one or two things just to be aware of that you need to know is that when you bring the point up from your X or your Z axis, whichever one you decide to go with, when the opposite axis is extended out, well, that line coming up must be perpendicular here. Okay, so that's a must with each of these axonometric questions. Okay, the next part of that is part B. So draw the elevation and end view orientated as shown and complete the axonometric projection. So the first thing we need to do here is to locate these portions of the plane here. Alright, so essentially what we're doing, when you're looking down here at the corner of the axis, imagining that's the corner of a room, essentially your triangle is not at 90 degrees to you. Okay, so essentially what we're doing, we're rotating that up, so you're looking at 90 degrees, and whilst we do that, that's giving us this triangle here for your end view and for your plan in this, sorry, your elevation in this case. Okay, so I'm just going to do that part next. So to project out those two triangles, as I said, you always project at 90 degrees to this trace of the triangle. Alright, so you have your point here, point A and B, we'll label those, sorry, A. So you have point A, B and C, alright, and as I said, you project out at 90 degrees to this trace here on the side. Project those points out 90 degrees, draw your line here perpendicular to the line of projection. Okay, bisect that line as you see here, and the reason we bisect that is to get the center point. You could measure it from halfway on the line, but I like to show that you can construct the bisector there just to show an examiner and just to try and gain maximum marks, and it's every bit as quick. Okay, you get your center point, then you swing your arc from B right around where that circle then intersects where the extension of the x-axis comes out, point C. That gives you point C, and you draw in your triangle. So I'm going to do the same thing on this other side. It's the exact same method, just it's on the left hand side of the y-axis. So now that I have my planes in on both the left and right hand side, I'm going to use them for my end view here and my elevation over this side. That's the first thing we need to get to do, and then we'll project our points back to get the pictorial view. Okay, so again, we're previously given our dimensions here, so I'm just going to work off those dimensions that given, and I'm going to carry on with the two sides. First of all, for the elevation here, we know it's 8.5 meters out. So this is going to act as our baseline, 8.5 meters. I'm just going to do that in red. Right, 8.5 meters out there, so I'm just going to go 85 when I convert that. Alright, and we know the sides are going to be coming up here. Okay, We're not yet sure of the height of that, because we need to get the height over here on our end view first. Okay, we know this distance is 4 meters. We're given that again, the radius 4 meters. I'm going to come out along the bottom, 40 in this case when we convert it. I'll draw the 40. Alright, so you can see from the image here the question we're given. You can see a few things here that's going to help us out with that. We're going to project up here at 90 degrees to this. Okay, we know the goalpost and the baseline is at 90 degrees. I'm just going to project that up first of all. Right, pencil for now, just until we're sure. Okay, I'm going to project that line up here, 90 degrees to the base of the goal, first of all. So this angle here, 90 degrees. We can see from our drawing here where that line crosses the trace of our plane. We're going to bring it across here, and that's where our curve begins. So that's a goal out, and that's how we determine the height in the first place. Okay, so because we're looking at the true shape of it there, if I come along, measure the height here either with the compass or measure with your set square. So 58 I see here. I can now transfer that over to this side on the elevation, 58 millimeters, and draw in the height of the goal. Alright, so now we can finish that goal off here as you see it. Okay, going slightly out over the border, so again that's just something to watch out for when you're setting up your axis. Okay, just to observe that from the off. Bring my height across. I'm going to bring it up here. The width we've already marked in along the baseline. Just be cautious just that they're intersecting on the corner. Okay, so now you'll see here I have my elevation, which is the front view of the goal in place, and over here I have my end view with the given dimensions. Alright. Sorry, so the next step, basically we have the elevation and end view. Next step we want to do then is to complete the axonometric projections. That's basically to complete the view along here in the middle. Okay, so we're converting our points, transferring our points from out here down parallel to the lines of projection, and likewise from the same corresponding points up here we're going to transfer them down. Alright, so I'll just show you that. Okay, we're going to start off. We already have the back line here of the goal started off. Just a little tip for this: if you start off, get the base or the footprint of the object done in first, and it'll make it a lot more easier to understand then. We have the back line done here. I'm going to bring the front line down here, which will give us the width of the goal, if you like, from the back to the front. The same points, I'm going to transfer down from this side. Okay, so I'm lining it up with the line of projection. Bring it from the corner here across. That there gives me this side of the goal. Likewise over here from this bottom corner, this side of the goal. So now we have what I'm calling is the footprint of that goal in place. You're just transferring the corresponding points from the view here. Same point down here is the front corner, and you see now the base of the goal. Alright, same thing with all the other points. This guy here, I'm going to project that down first of all. Alright, so I'm just going to call this, take this point here, project it down parallel to the line of projection. The same point here, okay, we can measure the height of that, which is 19. We know that height can be transferred over here, 19. And the same with this guy on the other side. It's the same height, so that comes down to the same line that's projected from the height here, and that gives you your height in this case. Okay, so them two can be projected up vertically, like so. From the bottom corner we have our height on one side, and then also on the other side. Okay, so now we have the base, we have the two front goalposts, the two straight little bits here at the back, and these guys also, the straight edge on both sides. Okay, this straight edge, this point is brought back here, so we can also draw them in there from the top of the goalpost back, top of the goalpost back, and now all we're left with here is basically to add in the two curves on your goal here, as you'll see it. Okay, the way we do that is we divide the true shaped circle here in this case, divide that up into maybe 3, 4, 6 equal parts, whatever is you decide to do. Okay, so I'm going to set up my set square here, and I'm going to do it from the center point, obviously, out at 60 and 30 degree angles. Now, it doesn't really matter how many you do, just as long as you show how it is you have it done. I'm going to come straight out here and here. Okay, so we have 3 points there. It doesn't really matter for now. You could go this way, which is probably the way I probably should have done it, and came out that way, which I have. Get your 3 points, so we'll call them 1, 2 and 3. Okay, what I need to do now is, with those lines, I just want to measure. I'm going to drop them down to the bottom here, onto the bottom of the goal. Okay. They can be then transferred down here onto the bottom and the sides here. I can project them up again, and then the actual point number 1, as you'll see. So I'm just going to take it down there. I'll do that in the color green just to show you. So again, our lines of projection. So remember where I dropped them down. Doesn't matter where you pick the points in the curve, but drop them down onto the bottom as I have here. Alright, just going to project that number 1 down. Project the number 2 down. Project number 3 down. Okay, while I have my set square set up, I'm going to do the same thing across here. Project 1 down, and we don't know where that yet stops, so I'm just using the colors yet to show that off. Okay. Your elevation, sorry, on this side. Your end view, they're getting no harm just to label the different views. And this guy here in the middle, well, it's the axonometric projection, which shows up your pictorial view. Alright, so that's it. The main 3 parts of the question. First, we set up our axis, got our isosceles triangle, projected out those views here, the portions of the plane on both sides, drew our elevation and our end view, and then our pictorial view in the middle. And note how you needed to complete half of one view before you could finish the other, if you like. So in this case, we had to finish off the in view in order to get the height to transfer over here to the elevation. And again, project your points back parallel to the lines of projection to get the complete drawing of the pictorial view. Alright, one last part with that question was a ball is positioned here on the ground at point F, okay, for a kick. Point F is 9 meters away, as you can see here, from the goal line, and is located in the direction shown. So this direction here is running parallel, as we can see, to the line of projection. Okay, the path of the ball after it is kicked is a parabola, which reaches a maximum height of 6 meters, having travelled a horizontal distance of 6 meters. By drawing the parabola in the in view, or otherwise determine whether the ball goes under or over the crossbar. So the first thing I'm going to do here is get the position of point F. Now we can see here from the drawing in the exercise that the point F is where the goal line crosses the bottom trace, or the horizontal trace, of the initial triangle. Okay, and it's running out parallel to our z-axis. Okay, so I'm just going to set the sliding set squares up parallel to the z-axis. where the goal line crosses the horizontal trace of the triangle out in that directions. Okay, so we know point F is coming out in this direction, alright. To get 90 meters away from the goal line, we'll come up to our end view where we're seeing the true shape because we're looking in from the end, and we're told it's 9 meters away from the goal line. Okay, so this point here is our point F. Okay, we're told the ball travels, if we look at the question again, the ball travels to make a path shaped parabola, which reaches a maximum height of 6 meters, having travelled a horizontal distance of 6 meters. Okay, by drawing the parabola in the end view, or otherwise, it says here, determine whether the ball goes over or under the crossbar. So what we need to look out for here, we're 9 meters away. We need to draw our parabola basically with these dimensions we're given: 6 meters of height, the maximum height, and having travelled a horizontal distance of 6 meters this way. Okay, so basically to grid out that and draw in our parabola for the last part. So that should be no problem. Draw in your parabola, come up your height of 6 meters, and it travels in 6 meters, and you will find whether the ball goes over or under the crossbar. So we're told the ball travels when kicked from F, it forms a parabolic shape, alright. It travels to a maximum height of 6 meters, which I've come up here, measured up 6 meters, when it has travelled at 6 meters distance. So by the time it comes over 6 meters from point F, it's at its max height of 6 meters here. So that means it's going to drop once it passes that point of 6 meters. Alright, so I just drawn out my grid here, divided into 6. So I've come 6 meters across, 6 up, divided 6 sections across the width of the box, and 6 sections up. So I'm going to grid it out as you do for your parabola and plot the points of the ball and where it travels. Okay, so it's back to drawing your parabola. As you see here, plot the points and you'll see the path of the ball as it travels along. So here you have 1 point, 2, 3, 4, 5 and 6. I'm going to join those points just to show the path of the ball to its maximum height. Okay, and if that ball then starts to drop the other side, well, we need to add in, obviously, see it's going to drop here if it goes over or under the ball. So I'm just going to mirror part of that until it crosses over that line. So again, I'm going to come out 3 sections here, we'll get as far as the line. I'm going to project those up. Project those up for now, the equal divisions I have there. So I projected across those 3 extra equal divisions just to reach the goal line. Projected my heights across because we're basically mirroring that along this line here. Those 3 points, and that clearly shows that once this ball travels and crosses the goal line, that it's actually gone in under the crossbar here, which is what we were asked in the question. So that shows all your construction lines, and all in all, that's the question complete. A nice question. That's your 2013 higher level. So again, part A, set up your axis, your isosceles triangle. Part B was to get your end view and your elevation drawn in, as well as your axonometric view. And part C then related to the position of the ball once it was kicked and whether it went over or under the crossbar. Okay, I hope that was helpful, and I'll be back to you again with further tutorials from here on in. Thank you.